There's some printing going on in the background. Don't mind it if you can hear it. We're at end number 15 right now, and this is about volume of prisms. We've done volume before, but we want to make sure that this makes a little more sense with prisms, not just solids. So volumes, I guess, and surface area is the big one that we're doing differently. Areas of prisms. Let's go with a thinner pen here. Now, a prism is a certain kind of solid. In fact, it's a certain kind of polyhedron. So here's some words I'm going to write out. You don't have to write them because I'm going to erase these in a second. Okay, polyhedron. You probably haven't seen this word before, really, but you've seen the word polygon. And we know that a polygon is a 2D shape that has, and it's an enclosed shape, and it has a certain number of sides and angles like that. Like this is a pentagon, sort of, right? So this is a polygon. A polyhedron is it's like a three-dimensional polygon. So let's say you have this pentagon here, and then let's say I grow a height into every portion like that, etc. And then I close it up. So a polyhedron is a certain type of polygon like that. Now, there are no real rules to what a polyhedron's lateral faces need to do. And I'm going to talk about all these different definitions here in a second. Okay, so that's a polyhedron. There's this other term which we're going to be using, and we're talking about here. These are called prisms, the ones we're doing today. Now, a prism is a polyhedron, but it has a top and bottom face like this guy right here, or like this guy right here, okay? See this triangle? It's a right triangle. This is the top base of the polyhedron, and here's the bottom base right here. They're both right triangles. Not only that, but they're both congruent, and they're both parallel to each other, and so they create rectangles here on the sides. So a prism is a polyhedron whose bases, imagine the top and bottom are your bases, are congruent. All right, so you're going to be playing with prisms today, 3 of them, and like I said, the first one's going to be a rectangular prism down here. So you have some stuff on the top that I'm going to refer to. These 2 formulas, volume and surface area, and we'll talk about what everything means right now. Volume is equivalent to, as it says, base times height, but this is a capital B, not a lowercase b. And when we refer to capital letters, we're talking about something that's area or volume or whatever else. We're not talking about length. So whereas height is a single individual length, base is, in this case, the area of your whole bottom thing. So when we talk about a rectangle and we say base times height, okay, notice the area is capitalized. The A is capitalized because we're referring to area. This B is a lowercase b because it's just a length. Here, when we do volume, we're talking about the area of the base. So it's not just one component. You have to figure out what the area of the base is. Now, it'll differ based on your problem. It could be a rectangle, it could be a triangle, it could be a circle, or it could be like a hexagon, right? So there are different ways to do those areas, either half base times height, or 1/2 AP, or pi r squared, or whatever it is. So there are all these different ways, which is why we generalize it to a capital B. And then again, multiply it by the height. So you get the area of the base, multiply it by this height, and then you get the full volume. You get everything inside, including the top, all that stuff. So you get the inside fill if you filled it up with water. Now, surface area, SA means surface area. Okay, and that is equivalent to the lateral area, which we're going to talk about, plus 2 times the area of your base. Remember, this B is the same thing, area of base. So surface area, as we talked about before, is the outer covering. So if I take this face and cover this face, like with paper, right? Imagine this is a real thing. And I take this face and cover it with paper. And this one right here. And there are 3 more faces. There's one in the back. There's one way back there. There's one on the bottom. Oh, well, I'm sorry, there are 3 more. There are 2 more. There's one on the bottom. So there are 5 faces, all which are covered. If I were to use paper, I wanted to know how much paper I would need to cover all of these things. So it is a 2-dimensional concept. When I'm looking for area, I'm looking for how much paper I need for everything. Paper is in 2 dimensions, so I'm looking for the area of coverage that I need for every face here. Now, what do we talk about lateral area and bases? Well, we'll break it down in a little bit because we've talked about surface area as find the area of each individual thing and then add up all the areas, which is true. But we're going to talk about this in a different way here. Just by understanding lateral area for a second, I'm going to talk about lateral faces, which are the faces on the side. And by that I mean these guys right here. Here's one, and in the back here, this is one way back there. So there are 3 lateral faces, for instance, for a triangle. And if it doesn't make sense, we're going to draw nets for these things, so they will. And bases, as I talked about before, they're the top and bottom faces. So for this triangle, here's a base, here's a base. Now, like I said, they're in a prism, they will be congruent. So they'll be the exact same. So when I see an 8 here, I'm going to write an 8 here, etc. So I'm going to walk you through 3 problems, and that'll be it. Okay, so the first problem I'm going to do, though, will be on the bottom. It'll be the rectangular prism. Now, nothing's drawn to scale, so don't assume that something's whatever. But this is a rectangle, for all intents and purposes, which they probably should have given you some right angles to tell you that. So if this is 8, opposite it is an 8. And below it down here is an 8. Now, one thing I didn't mention, well, I might have, but the lateral faces in prisms are always rectangles. So when you see these right here, these are rectangles. So this is 8 and 8, etc. And this is a 5 right here. So down here is also 5. Now the height is the same everywhere as well. So all these are 20. So this should all help you out very well. And if you can't imagine this, what's back here, transparently through there, it looks like that. So when you count the number of lateral faces, the ones on the side, if we are to unfold this thing right here, because remember we've done unfoldings before, I'm going to take this and unmap it to just a large old rectangle. And I'm going to divide it into 4 faces. I'm unfolding the lateral faces here, and I'll divide them into 4 parts. There'll be units of 5, 8, 5, and 8. And unfortunately, I don't have a cube right here to show you exactly what this looks like. So you're going to have to go with what we've done in class and hope that that works out. Refer to what we did, though, when we made nets. This portion right here covers everything on the side. So this front, this back, and this left right there. So all those 4 things got unfolded into lengths of 5, 8, 5, and 8. Now this height is 20 all around. Okay. Like so. And we have to unfold the top and bottom, these bases right here. And it was always best when we did it right on top of and right below one another on the side. So if I took this 8 right here and I unfolded a base, let's see, get it to look like that. I unfolded this base right here and this base right here. This is what you're kind of familiar with. So these represent the top and bottom portions right there. Now what are the lengths? Well, it's a rectangle still, and it's an 8 by 5 rectangle. You'll notice if this is an 8, this must be an 8, and so is this. And the other sides must be 5s. The other reason why they must be 5s is because imagine if you folded this thing together again. You fold all these 4 pieces, and then you fold this downward, and you fold this downward as well. I'm doing hand gestures. I know you can't see them, but just go with me. Now these 5s have to connect. These have to fold and hit each other at the exact same spot. That's why these must be the same, and these must be the same, etc. So these always must be the same, this number and this number, if you want to close them up to form a certain prism. Okay, now I've drawn my net, and I'd like you to draw the net when you do this. The next thing I'd like you to do is find the area of everything. Now we're going to do it one way, and then I'll show you another way after. So I find the area of everything here, 5 times 20. So base times height, 100, 160, 100, 160. And up here, we have 40. Now, these are square centimeters right here, like 100 square centimeters, etc. I'll ignore that for now and save it for the answer. I find the area of each individual rectangle. Then I add up all of the areas. That gives me the surface area. So 100. So this is 260 plus 100 is 360 plus 160 is 520 plus 40 is 560 plus 40 is 600. So the surface area is 600 square centimeters. And the question is, I mean, sometimes you'll recognize patterns. Like, for instance, one definitely recognizable pattern that I want you to know right now is these will always be the same. They must be, because we're referring to prisms, so the top and bottom have congruent bases. So 40 and 40. So if you find the area of one, then the other's the exact same. So if you have to do some extreme calculation, you can save yourself some time. You only need to do it once. The other thing, I mean, here for a rectangular prism, you'll see that 100 and 100 are the same, 160 and 160 are the same. That won't always be the case, except for in rectangles, so you just got to be careful. But there is this relationship among these guys, or among this whole thing right here, if I called this an entire rectangle. Because remember, what I did initially, when I talked about drawing a net, was I started with the rectangular piece and I just brought it all out. Now, I don't know if that's assumed that I can do that, but I did it because we've always been doing it, so that's kind of the assumption I played, and then I divided it into parts. And the thing you want to ask yourself is, well, when I divide it into parts, I mean, I still have a large rectangle here, so maybe, just maybe, I don't need to find the area of each individual rectangle, because the area of all four rectangles added together is the exact same as the area of this big green rectangle right here. So what if I just took this 5, added it to the 8, added to the 5, and added to the 8, just took the entire length, whatever that is. 5 plus 8, 13, 5 plus 8, 13, so that's 26. What if I take 26 and multiply it by 20? Now remember, this original thing was 520 right here. 26 times 20, you can use your calculator. Guess what you're going to get? 520. So the area of this entire rectangle obviously is the same as the area of these four rectangles added together. And now the question is, well, first of all, why did I draw a net? Well, a net helps you make sense of some things, for instance, where you put your bases and everything else. But also, it helps you get an understanding of what this whole unfolding process is. When I unfolded this, keep in mind, look at these top numbers, 5, 8, 5, 8. Is that not the same as these four numbers here? 5, 8, 5, 8. Well, the answer is no, there is no difference. So, if there's no difference, and I add these together and get a number, and then multiply it by that height right there, what am I really doing? Like, if you ignore this net right now, like just completely just stop looking at it for a second. If we ignore that and just look at this, what do I essentially get when I add 8 here? 5 plus 8 plus 5 plus 8. And the answer is, you see this base up here? I just found the perimeter of that base when I did 5 plus 8 plus 5 plus 8. Okay? Now if we undo that again, that was 5 plus 8 plus 5 plus 8. So when I look at the net drawing, the width of this big rectangle right here is the same as the perimeter of your base in your prism. Okay, so the unfolding of it, and again, I'm using my hands right here, you can't see them, but the unfolding of this object here gives you the perimeter of your top and bottom guy, of this guy right here. This 5 plus 8 plus 5 plus 8 is the same as this 5 plus 8 plus 5 plus 8. They're the same thing because they connect when you fold them together. And then this 20 right here is the height of your prism, because it's 20 all around. Okay. Another mathematical way to do it, if you think about it, well, I mean, I'll do it mathematically, but a way to look at it mathematically is by actually doing is by actually finding the area of all these. We did 100 plus 160 plus 100 plus 160. Well, mathematically, what we had to do was find the area of each. We did 5 times 20 plus 8 times 20 plus 5 times 20 plus 8 times 20. Okay. Now, before I solve this and actually multiply these out, check out this common factor of 20. What if I factor the 20 out? I factor the 20 out of each term. What's left is 5 plus 8 plus 5 plus 8. So you'll notice, again, this is height. Let's do this in a different color. This is height. And this is perimeter of your base. And by base, I mean this top guy or this bottom guy. It doesn't matter. Perimeter of the base. So surface, so lateral area. I'm going to go back to lateral area one more time. Your lateral area, the area of your lateral faces, the guy in the green rectangle, is equal to, I'm going to do perimeter first. The perimeter of your base times your height. Okay. Right now, for the sake of time, that's the best explanation that I'll give. If you have more questions on it, you go rewind again and see if you can make sense of it, or then you actually start asking questions on the forum. And again, I'm going to do the other two problems like it, and I'm going to start speeding up through the problems. I just want to make sure surface area makes sense here. So lateral area is the area of your lateral faces. So this whole green guy is your lateral area. The 2b is finding this b, multiplying it by 2, because these are the same area every time. So we found the area was 600. Let's do it with the use of the formula here. Surface area equals lateral area plus 2 times b. And like I said, this is a conventional shortcut method to it. It's not the, oh, look, you have to memorize this. Or better yet, it's not the, oh, you should memorize it. But the understanding of how this gets condensed into such a shortcut, instead of saying taking the area of each, then adding them together, I want to make sure that you get that difference there and say, well, okay, I can condense this a little bit if I just find the area of this, the area of one of these, and then I have enough information. I really do. And in fact, you don't even need the net here. The net gives you an understanding of what you're doing, finding area, but the area can really be found with all this. Find the perimeter of this, add these up, multiply it by 20, then you have your lateral area. Find the area of one of these, multiply by 2, you have the area of both of these guys. Okay? So if surface area is lateral area, which is 520, plus 2 times b, which is 40, that equals 520 plus 80, which equals 600 square centimeters. Okay? Two different ways of doing it. Formula, if you want to call it that, or process, better yet, or adding all these up once you figure them out. Okay? There's really no wrong way, but it's going to help when you start looking at some other problems and you haven't really used them before. Like we're going to look at the triangle and the circle above. A circle, by the way, a circular prism is also known as a cylinder. We're going to talk about that. Now, volume, remember, it's the area of your base times the height. So we have to find the area of the base. And in this case, the area of a rectangle is base times height. So we do 8 times 5 for that. That won't happen for each one, though. For a triangle, obviously, it's half base times height. And for a circle, it's pi r squared. So they're different things. It's not always 8 by 5 by 20 or whatever else, depending on what the shape is. In a rectangular prism, though, it is. So it's the area of the base times the height. 8 times 5 is 40. 40 times 20 is 800. Cubic centimeters. Okay? Volume, like I said, will be pretty simple. You just have to make sure you understand what the area of the base is when you do it. And you have to use your calculator, I guess. Okay, I'm going up to rectangle. Like I said, I want to try and speed this up a little bit. Now, maybe they won't give you all the information in a problem. Like, for instance, they give you some lengths. Like, remember, these are rectangles right here. Your lateral faces are rectangles, so I know this is 8, this is 15, and I know these are 7 everywhere. We are missing one piece of information, though. We're missing this. Okay? Now, sometimes they'll ask you to solve for these things, which in this case you can. This, look at this. This base is a right triangle. This is 15. This is 8. To solve for this, let's call it C. You can use Pythagorean theorem. A squared plus b squared equals c squared. Or, if you know this is a special right triangle, if you know some of your special triangles, this is an 8, 15, 17 right triangle. So you'll solve for C. You'll get C is 17 meters right there. So you solve for that, you get 17. This is 17. Whoops, this is 17 as well. So you're all good. But like I said, something you need. It is something you need because when you draw the net, which is something else we need to practice here, you need to make sure you have all your lengths. Okay, my net, again, I'm not even going to quiz you on this. It starts with a rectangle. These rectangles unfold to make one big rectangle of lengths 8, 15, and 17. Okay, notice they unfold. This 8 unfolds here, this 15 unfolds here, 17 unfolds here. So I get 8, 15, and 17. Remember, this is the lateral area. I should make this thin again. Your height all the way around is 7. 7, 7, 7, etc. So these are all 7s, just in drawing your net. Okay, this part's not that difficult. Unfolding a lateral area into, or your lateral faces into a big rectangle, split into different ones. This base part is a little more bizarre, though, and I'm going to make quick sense of it if I can. I don't have something to unfold and fold for you in front of you, but remember what we do when we unfold it. We unfold these rectangles, bases are still on top and bottom. If you unfold this upward, like so, if you unfold this upward and you unfold this downward, maybe this way, in the direction of the 8s, what comes up from this? Well, the 15 comes up here, and the 17 goes over there, so it looks like that. Okay, trying to get visual perception here. Here's 15, here's 17, here's 15, here's 17. And if these unfold outward, like those guys right there, etc., okay, you'll see what kind of net you're looking at when you get this. But I unfolded the 17 out here, so your net, I just covered my screen with my hand. This is awkward. My net looks like this stuff right here. Let's make it all green. So my net in a 3D perspective, if I unfolded paper, looks like that. Only if you unfold it from the 8s. You can unfold it from any one like that. So if I unfold it from the 8s, it's going to end up looking, I'll keep it like that, it's going to end up looking like this. Up here, that gets unfolded. Down here, that gets unfolded as well. Okay. Now this is the right triangle portion. And remember, these two things have to be the same. That's what makes this a 15. And that's what makes this a 15. And obviously it does because it's the other leg of the right triangle. And these are 17. Now these connect all the way over here with these. When they're all folded together, these must connect as well. So it depends on how you draw your net. Okay. Now this is one way of drawing it. And I'm going to erase this. So if you want to keep this, go and keep it on your paper. I'm just going to erase this and draw another way. Make it a little better. Save my room for volume. Let's draw it starting with the right triangle on the 15 instead. Unfolding from the 15. If I unfold from the 15, my other leg, 8, has to be over here. And here's my hypotenuse 17, which again should connect when they fold together. Maybe it doesn't look like it right now, but if you played with a piece of paper that looked like this, you'll see how they do connect when you fold everything together. Now keep in mind, there were only 3 lateral faces here. 1, 2, 3. And there are 2 bases, which make a total of 5 faces. Now I'm going to keep my net like this. Okay. Now, a conventional way to find the surface area is finding the area of each individual polygon, I guess, of each individual polygon and then adding them up. Now remember, these are rectangles, 8 by 7, 15 by 7, 17 by 7. But the other way of doing it is remembering that this is just one large rectangle. Not only that, but this rectangle is the equivalent to taking the perimeter of your base, like this triangle, 8 plus 15 plus 17, 8 plus 15 plus 17, which is 40, by the way. This whole thing is 40. And then multiply it by your height, which is 7. That'll give me the area of this whole thing. That's called lateral area. This guy right here, lateral area, is taking the perimeter of your base and multiplying it by your height. Okay? We unfold it, it looks a little more simply like a rectangle. So 40 times 7 is 280. We're not done. We still need to find the area of one of our bases. Now the area of a base, it's not just base times height, it's 1/2 base times height, because this is half of a rectangle. So 15 times 8, I don't even know what that is, 15 times 60, is 120. Half of 120 is 60. So the area of one of these is 60, which must mean the area of the other is 60. Again, you don't need to write that. You can do 2 times 60 plus 2b, right? Because they're both the same. 2 times 60 is 120. 280 plus 120 is 400 square meters. Okay. Your volume is taking the area of your base, which we already got. We got it as 60. So the area of your base times your height, which is 7. So it's simply 60 times 7, which is 420 square meters. I'm not even going to take time explaining that one. It does come pretty naturally. And finally, the circle. Not too difficult in terms of finding volume again. It's still the area of your base times your height. You just have to make sure the area is pi r squared for your circle, etc. You have to make sure that you know these are both the same. These are both 5 centimeters, all that. Surface area is going to be a little different, though, because you probably can't perceive this. And you probably still won't be able to when I talk about this. But I want you, if you're at home, I want you to find a toilet paper roll. In fact, I want you to find toilet paper. Start unwrapping the toilet paper. Start pulling it and rip some out. What kind of shape do you make? When you rip out that toilet paper and you lay it out flat, you don't make anything circular. I mean, again, don't take my word for it. Go and try it. You make a rectangle. Toilet paper unfolds to a rectangle. So this whole lateral area, this side facing, is actually just a rectangle. It's just that it curves in. It doesn't fold in. Now the top and bottom are circles, and this is what's going to look really weird here. Your top, if I unfolded it upward, like up this way, it's just a circle like that. Okay? And your bottom is also just a circle like that. So this net is a little weird looking, and it's different. Let me make that a little bigger. Well, not much bigger. And it's different, definitely. But this is surface area. You take these, if I curved it all in, like this, I curve it and close it and lay this one down here, and I lay this one down right there. That makes your cylinder. Okay, this circular prism is otherwise known as a cylinder. It's only not the same because the lateral faces don't fold, and they don't make different rectangles. They unfold to make one large rectangle. Now the super question, though, is what is this length? Because you can't add anything here. I didn't make individual rectangles. Well, again, before when we did this, these were numbers that were the perimeter of your base. So go figure, this is also the perimeter of your base. But we have another word for this. This is called the circumference. So this guy right here is your circumference. Circumference is 2 pi r, or diameter times pi. We have the radius as 5. So the diameter is 10. So your circumference is 10 pi centimeters, by the way. Okay? This length is 10 times pi, and I don't want to round that number. Let's leave it in terms of pi if we can bear it. This is 13 centimeters. This is your height, still the same thing. And we already know this is 5. This is 5. Oops. So your surface area is your lateral area. We need to find the area of this thing, which will be base times height, 10 pi times 13, which is 130 pi square centimeters. That's your lateral area. 130 pi plus 2 times the area of one base. Area of this base is pi r squared. So pi times 5 squared. 5 squared is 25, so that's 25 pi square centimeters, by the way. 2 times 25 pi. So 2 times 25 pi is 50 pi. 130 pi plus 50 pi is 180 pi square centimeters. Okay. Volume is area of base, which is 25 pi. We already got that. Times height, which is 13. 25 pi times 13, shoot, I don't know what that is. 13 times 5 is 50, 65, 195. I'm going out on a limb here. No, gosh, that's not even close. I didn't add that right. 13 times 2. 260 plus 65, 325. I hope that's right. 325 pi cubic centimeters. This is supposed to be square meters here as well. All right, so hope that all makes sense.